Two quick things I want to show you before we wrap things up. One is how to find the general equation, and the other is how do you find the domain. Very, very challenging, and I'm going to just show you real quick here. Let's take this one for example. Let's say I wanted to find f of g of x. Which is the inside and which is the outside of f of g of x? What's the inside, f or g? G is the inside because it's inside. This is what we're going to put in the inside, and this is the outside. So when I'm doing this, here's what I do. I take the f function and I write 5x plus 1. So I do this as the outside. Then in for x, what do I put in for x? G of x, right? So I go x squared minus 4. Are you okay with that? Let's try the next one. G of f of x. So now we have g of f of x. Now what's on the inside? F of x, and g is on the outside. So I like to do the outside function. I take the outside function, x squared minus 4, and what do I replace the x with? F of x, 5x minus 1. How are you doing with that? Is that part okay? Easy. Domain, not so easy, but we can do it. What you're going to do for figuring these out is you're going to, for this one, you're going to define the domain. You're going to take the domain of the inside and intersect it with the domain of the outside, which in this case is f, with g of x plugged in. That looks complicated, doesn't it? Looks kind of complicated. But what you do is the domain for this one, they're saying is x is less than 5. The domain for this other one is x greater than or equal to 1. So if we're looking at the domain of f of g of x, we take the domain of the second one, which is x greater than or equal to 1, and intersect it with the domain of the second one, the outside, x less than 5. But what are we putting into the function? We're putting the inside function in. So I go with this g of x, which was my inside. That goes in here. And then we solve for x. I know, it's tricky. X is greater than or equal to 1, intersect. X squared, add 5, you're going to get 0, or no, 10, right? So x squared is less than 10. When I look at my number line, x squared is less than 10. If you squared it, took the square root, what's the square root of both sides? Square root of 10, which is around 3. So here's the square root of 10 and negative square root of 10. And it's between there, so it's somewhere in between. Then we're going to intersect it with x greater than or equal to 1, like this. And what's the intersection of this? One to the square root of 10. I know, complicated, isn't it? You didn't think this was going to be that hard, but I think it's kind of tricky. Let's try this next one. G of f of x. So what we're going to do is we're going to take the domain of the inside, which is f of x. We're going to intersect it with the domain of the outside with inside plugged in. I'm not going to say inside, though. I'm going to say g of x plugged in. Okay, so the domain of f of x was x less than 5. We're going to intersect that with the domain of g of x, which was x greater than or equal to 1. Now, for this box, we put on the inside, we put 5x minus 1. That's the inside function, f of x. So put that in. 5x plus 1. So now we have x less than 5, intersect 5x, subtract 1, greater than or equal to 0. X is going to be greater than or equal to 0. Now we draw a little number line, and we're going to have 0 and 5. And so x is less than 5. X is greater than or equal to 0. The intersection is what? Oh, such a quiet group. What do you think, Lucy? Just 0 to 5, yeah. That's the domain of the combination of g of f of x. Guess what? We're going to work on that tomorrow further. So we'll keep working on these. If they seem hard, it's because they are. And then for tomorrow, all you're going to do is you're going to do all these circled ones, which you said was easy. And then would you go real quickly to number 56? It's my personal favorite. G of f of 1. So look at this graph. What from the graph is f of 1? From the graph, what's f of 1? 2, right? Do you agree with that? F of 1 is 2. Now, what's g of 2? 3. Good. Turn to your neighbor, see if you can do 58. This is the same as g of f of 2. Perfect example of composition of functions. So f of 2 is what? 3? So what's g of 3? Uh-huh. How many had 0? Very good.